Hi there, this is Amanda, and this is going to be the second video in the tutorial. So this is the Module 2 video. So just as a reminder, you want to make sure that you've went to the Google Drive and you've pulled all the files from that Module 2 folder. And so there's 3 different files you need. There's a PDF that you can follow along with. There's the R script that's going to have all of the code we need for this module. And then there's going to be a data set that we need as well. So I'm going to go ahead and open up the Module 2 script. And then just as a reminder, remember that RStudio is broken up into 4 windows. We've got this one right here, which is where we can view our script. And remember, you can think of a script as being, kind of like a Word document, but instead of typing, text that we're going to read, we're typing code in here as well. Down here we have the console, and this is where we can run code line by line and see the output. We also have the global environment, and then we have this extra window, and this extra window is where we've got a file explorer. As you're going to see in this video, we can create plots in here, and there's some other stuff. So let's go ahead, just as a reminder, let's use that file explorer, and what you can do is you can navigate through your PC, and you can find where that folder is that has those 3 different documents that those 3 different files rather, that we just talked about. I'm going to Module 2, and now we'll see those 3 files located here. And the very first thing we're going to do is set our working directory. So I'm going to click on More, Set as Working Directory, and notice it automatically generates the code for me. Then for later use, I can always copy this code, and I'm going to paste it over top of this old working directory I had up here. All right. So my working directory is set. And remember, we set our working directory because this lets R know where all of the files that we need are going to be. So when you're working in R, whatever folder you have your data set in, you're going to want to make sure you set your working directory to be that folder. All right, just like last time, the very first thing we need to do is read in our data. And so remember last time we saw that read.table function. So I'm going to run that. Notice our practice data appears here. We can always click on it to see the data set, double check that everything looks the way that it should. And then you always want to do a couple different checks just to make sure, does everything look right? And so what I've got here are a couple lines of code that can help you do those checks. And so anytime you read in the data, always perform a couple checks to make sure it looks okay. So you could use what's called the head function. So notice we've called the function head, and inside the parentheses we've put the name of our data set. So we can run this. And what the head function does is it just produces the first 6 rows of the data set. And so this is a good way to check to make sure all of the columns are there and that the format of the data looks reasonable. Tail is going to do something similar, except instead of letting us see the beginning of the data set, it's going to let us see the end of the data set. We could also, like we saw last time, another way to print the first 5 rows is we could use the bracket notation. So we get the first 5 rows, or maybe we just want to see some of the columns. And so here's a way that we could look at the first 2 columns. All right. Now one thing to notice here is in this case we wanted to see the first 5 rows, so we use the 1:5. And so that colon, what that means is the numbers 1 through 5. Let's say that we just wanted to see the first, the third, and the 5th row for some reason. Well, if we wanted to do that, we could type in the name of our data set. Again, use our square brackets, put our comma in the center. Now remember that anything I put to the left of the comma is going to signify rows. Anything I put to the right is going to signify columns. If I want to specify which rows I want to see, what I can do is I can type C, open and close parentheses, and then inside of here I write out the number rows that I would like to see. So let's say I'd like to see the first row, the 3rd row, the 56th row, and the 78th row. So let's run this. And notice here we get the 1st, the 3rd, the 56th, and the 78th. So that's one way if you wanted to specify specific rows, you can see specific rows, and you could do something similar for the columns. And then just a reminder from last time, remember these are some different ways that we could view the explanatory variable column. And either one that we call is going to give us the exact same output. All right, what we're going to look at first is just how to look at some different descriptive statistics in R, and then we're going to move on to look at some plotting. All right, so the first function that's very useful is the table function. So the table function is useful when you have a categorical variable. And so if you'll recall, one of the categorical variables we have in this data set is the group var2 variable. And so we could again click on our data set. Notice that group var2 takes the values A and B. And suppose I would be interested in how many times A and B are appearing in my data set. What I can do is use the table function, and notice here we're calling the group2 column. So if we run this, we're going to get a table, and notice that it tells us the letter A appears 50 times in the data set and the letter B appears 50 times. Now notice when using the table, it doesn't tell us where the A's and B's occurred. It just tells us the number of times they occurred or the frequencies, and so this is a frequency table. One thing that you might be interested in is the number of missing variables that you have, or missing values that you have. So here we're going to call the toy var, or the toy variable column. So again, if we go here and look at our toy var, notice that there are some missing values in this column. So in order to do that, we actually combine two different functions together. We have the sum function and the is.na function. The is.na function, just so you can see what it does, I'm going to copy it just by itself. What it's going to do is for each of the values in this variable, it's going to produce a false if there was an actual number there, and a true if there was a missing value. Then what the sum does is the sum adds up all the trues and falses, where the falses are a 0 and the trues are a 1. So if we look at this, we see the sum is equal to 4. So for toy var, there are 4 missing variables. So notice here in the toy var, notice that the first missing variable occurred for observation 9. And if we go back and we look and we count here, this first true that we find corresponds with the 9th observation. Okay. You might be interested in the mean and the standard deviation of a particular variable. So again, we're going to work with that toy var variable. Now one thing that you've got to be careful of is, suppose that I want to know what the mean of this variable is. So I'm going to run this, and notice it produces an NA. The reason for this is that there are missing values for this variable. Anytime that you have missing values for a variable, R cannot calculate the mean or the standard deviation. You have to tell R to remove those missing values before calculating the mean and the standard deviation. So you'll notice here, the second time we call the mean function, we added in na.remove equals true. So the na stands, that's how R denotes missing values, .rm stands for remove. So we're going to remove the missing values before we calculate the mean. And notice this time when we run it, we actually do get the mean of that variable. We could also get the standard deviation using the function sd. Now in both of these cases, we've just called the function, so down here in the console, after we call it, it gives us the value. Suppose that we're going to want to save that value for future use. Well, what we can do is we can assign it to be an object. So notice here to the right, we have that same function call we saw earlier with the mean, and then we have arrow mean.practice. So if I run this, notice that now in my global environment, I have a new value called mean.practice, and it's equal to that mean that we found down here. Now a couple notes about this. One, remember that the arrow is the same as an equal sign, so I could put an equal here as well. Also, the name that's to the left of the equal sign, sorry about that, that name is completely up to you. You can call this whatever you want. So I could call this Amanda.mean, for example. And notice if we run this, Amanda.mean now appears. So what name you put to the left of the equal sign is completely up to you. What is to the right of the equal sign, that's where you're calling objects or data sets that are already located in R or that you have loaded into R. Some other common descriptive statistics that you might want are the min, the max, median, range, and you can find all of those here. Or you might just want a summary that includes a lot of pieces. So you can use what's called the summary function. And the summary function will give you the mean, the median, as well as the quartiles, the minimum, and the maximum. And you'll see all of those here. It also tells you the number of NAs, or the number of missing values for this particular variable. And you'll notice that that matches with the number of missing values we found early on. You could also find the quantiles. And so notice here you've got the first, 25th, 50th, 75th, and 100th, and notice that these match exactly with what we got here using the summary function. So all of these are options to get different descriptive statistics for the variables from your data set. Next, we're going to look at some ways that we can plot data. And we're going to start out with plots looking at single quantitative variables. And so a very common plot that you might want to make is a histogram. So the histogram function is HIST, and you'll notice for this function we're going to call the response variable, so you could put whatever variable you wanted here. The main option, what that does is that is your title, so we could change this title to whatever we want. The XLab, that changes the label on the x-axis. There's some other options here that I have commented out, but remember you could just take off the hashtags here to make those run. So frequency equals true, that will change the histogram to being counts. You could change this to specify a series of points, and then that's for the breaks in the histogram. The limits set the limits of the x-axis, and the y-lim sets the limits of the y-axis, and then you can also change the color. So let's run this. Alright, so here is our histogram. And so let's change a couple things here just so you can see how this changes. Notice that right now the x-axis runs from 20 to 70, which is reasonable for this data if we look at the summary of this variable. So let's do that. So if I wanted to look at summary, of the response variable, I see that the minimum here is 23.29 and the maximum is 64.8. So that's a reasonable distance there to have on the x-axis, but just for illustration, let's see what happens if I change this x-lim to 100. Notice now we get this extra space down here, so that's how you can control that. You can also control the height here. So to do that, we change the y-limit. And so right now, and usually by default this happens, the y-axis ends at 20, but the bars go up a little bit higher. So I'm going to change the y-limit to be 0 to 25. And then actually before I do that, let's change this back to 70. And notice that y-axis looks much better now. Now one thing that I want to show you is, again, remember that you can always move the windows in R. What I'd like you to do is to make this plot really tiny here. And notice if we try to run this, we get an error. So anytime that you get an error in plot figure margins are too large, all that means is that you need to make this window bigger, and then you can rerun and the plot will appear. And so that's a common thing that happens, especially if you've been moving these around to make it easier to see the code. Right? Next, what we're going to do is we're going to check how many missing values we have for that response variable, as well as the second toy variable. So we have none for our response and 4 for our second toy variable. And remember, you always want to be checking whether or not you have missing data. So let's see how to make a box plot of the response variable. So to make the box plot, we use the box plot function. And notice here we have a box plot. but this box plot isn't very visually appealing. We can definitely do better than this. This is just the default. So let's add in some options to make this look nicer. So one thing I'm going to do is I'm going to change the title using the main function. I'm going to add in a y-axis label so we know what that represents. Here we're going to have the names be all data, and you'll see this here in just a second. We're going to change it to be blue, and we're going to include the outliers. All right, so notice this looks a little bit nicer now. Notice that we didn't have any outliers, so no outliers actually appeared here, but if we did have outliers, they would have shown up. So that's how we plot one quantitative variable, or some of the more common ways. So next, let's look at how we can make some plots of a single categorical variable. So a very common plot with a single categorical variable is a bar chart. So in order to make a bar chart, we actually have to use the table function and create a frequency table first. So that's what we've done here. First, we're going to make a table of the variable group var. So in order to see what this table looks like, we've assigned this table to be the object plot.group. So now we can just run plot.group by itself and the table will appear. So notice we've got 50 control and 50 treatment. So then to make a bar plot, we don't actually call the data. What we call here is the frequency table that we created. And here is our bar chart. Notice this isn't a very exciting bar chart because we only have 2 groups and there's 50 in each group. So it kind of just looks like 2 boxes next to each other. But you could use this, if you had more than 2 groups, if you had different value, or probably different frequencies for the different values that this variable could take, and this would make a much more interesting plot. You can also make a pie chart in a similar way. Again, instead of calling the actual data, you're going to call the frequency table that you created. And so here's our pie chart. And again, not a very exciting pie chart because we had 50 in each group and only 2 groups, but this is here to illustrate how you would create one of those. So we've seen how to create a plot for a single quantitative variable, a single categorical. Now let's look how we could compare 2 variables. So you might want to compare one quantitative and one categorical variable. And a common way to do this is to make side-by-side box plots. So you could just make the default box plots. And so notice here, my categorical variable is the variable group var, and it took 2 values, control and treatment. And these are the box plots for the response variable for those 2 different groups. Now, how the code works here is you call the response variable, so we've got practice data $response, and then you have a tilde, and then you have the group variable or the categorical variable. This tilde right here is what is telling R to create the box plot for the 2 different levels of the group var, or of that categorical variable. And just like with the single box plot, you can make ones that look a little bit nicer. So here, what we've done, we've changed the title. We've added some names down to the bottom. Notice we've got control group and treatment group. We've got the colors green and blue for the 2 different box plots. On the y-axis, we've put response variable. And then here we've got parse list, and what this is doing is this is creating these 4 different vertical lines that make it easier for us to make the comparison of the box plots. So notice these 2 vertical lines correspond to the min and max for the treatment group, whereas these 2 are the min and the max for the control group. You could also do side-by-side histograms. So in order to do this, we're going to create 2 data subsets, one for the control and one for the treatment individuals. And you saw something very similar to this in the last video. So now we've got our 2 subsetted data sets. We've got the control data and we've got the treatment data. So to make the histogram side by side, what we're going to do, delete that comma out here. So we make the first histogram. which looks like this. And then we make the second histogram. Oop. We've got this misspelled. This will be fixed on your side, or when you see this. There we go. And here is the second histogram, but ideally we would like them on the same plot. So to put them on the same plot, I'm going to add that comma back in, and I'm going to uncomment the add equals true. The add equals true is going to add the second histogram to the first one. So I'm going to run both of them again. And then the box function, which is going to add that box around them. And now we have side-by-side histograms where we can compare the response variable for both the treatment and the control. You can also make a scatter plot, which is another really common way to compare to quantitative variables. So in the most basic type of plot, we use the plot function. You'll notice here, first I'm going to call the toy var variable, and so that's going to be your explanatory. And then we have comma, the response variable, and the main equals makes the default scatter plot title. Just like before, we could add in options to make the plot better. Some of the things that we could add is we could change the title to be more informative. We could add a label to the y-axis. We could add a label to the x-axis. PCH equals, these are different plotting symbols. So let's run this. And notice our plotting symbol turns to now these small dark circles. PCH equals 20 is the one that I prefer the most, but you can put in all different kinds of numbers and get different symbols. Here are some other options. You can change type equal to B. This is going to make a line plot. If you're going to do this, you do want to make sure your x's are ordered, whether it be through time or whatever makes sense to have that be a line plot. And then you can also change the color. So here we've got all of the points are black, but you could change those to blue or whatever else you want. There are also other types of plots that we could look at. So let's look at some examples here. First we're going to do is find the range of the variables we're interested in plotting for both groups. So here what I've got is the Y data range, and this is going to be the data range for the response variable, and this is going to be the range for that toy variable. And so notice the reason I've named them Y data range is because we've got the response variable on the y-axis, and X data range because we've got the toy var on the x-axis. So notice these two now appear in my global environment and I have the range. So now let's make a scatter plot, and this scatter plot is going to have both the treatment and both the control data. So first, in this plot, what we're doing is we're setting up the plot so that it's ready to plot the control data for the toy var and the response variable. These lines are actually going to add the points. These lines are going to actually add the observations for the treatment. And notice here that as soon as it said it couldn't find an object, automatically I knew that I had probably misspelled something or misspecified something. So that's how I knew quickly I needed to change that over to treatment, which is what I've called the data set here. All right, so notice now we are now looking at three different variables. We've got the toy variable on the x-axis, the response variable on the y-axis, and we're using color and shape to denote our third variable, which is the treatment versus control. And then we could add a legend to the plot. So now we've got a nice scatter plot where we can compare what is going on between the treatment and the control group. Another thing that we could do is all the plots that we've looked at have had a single plot in our panel or in our window that we're looking at. You could also use what's called the par function to change the number of plots that are shown in a panel. So here we're going to run par mf row, and then what this does is this combines the 1 and the 2. So we run this, and what it's going to do is it's going to create a plotting window that has 1 row and 2 columns. If we switched it, sorry, I misspoke. That's going to create a plotting window with 2 rows and 1 column of plots. So let's see what this looks like. We're going to run 2 different histograms. And again, I've got to change that over to treatment data. And so notice now I've got 2 histograms, so 1 row, 2 columns, and I can compare my 2 histograms side by side. So we saw the option where you could overlay the histograms. Here you can look at them side by side. If you use the par option, you always want to make sure at the end to reset it to be 1, 1, because the 1, 1 is just going to be one plot in the entire window. Alright, everything that I've shown you so far in R has been using what are called the base functions. So the base functions are all there when you download R, but that's really only a very small portion of R. There are many contributed libraries that can be downloaded and called into R that extend on this base package, and that's really what opens up R and makes it to where it's so flexible and can do lots and lots of different things. So I just want to show you a little bit about the libraries and the packages and how these work so that you know if you find something you want to do and it requires one of these packages that you'll be able to do it. Alright, so in order to illustrate this, what we're going to do is we're going to call what's called the MV norm function, and what this does is it draws values from a multivariate normal distribution. If you haven't heard of that, don't worry. It's more I just want to illustrate what happens if you try to run a function and you don't have the package installed. So if we run this, notice it's going to say that it can't find this function. So anytime R gives you the error that it can't find a function, that probably means that you need the package. So in order to get any package, what you'll want to do is go to the top and click on Tools, Install Package. This particular package is in the mass package, so you'll find mass, click Install. And then after you do that, you'll call it again with the library function. And now let's try to run this function again, and you'll see that it works. So in general, whenever you're going to install packages, you could run the function install.package, and then you type in the package name, and then you'll type in library, the package name. So you always do these 2 steps together to get whatever packages that you need. And so these are some common ones that you might see used. And then just as a word of caution, sometimes when you add a new library, it might have functions that conflict with other functions that had already been specified. And so they end up that the functions have been masked or hidden. And so here's just a quick example of that. If we call the MATLAB package, so let's install this one really quick. And we use the matrix function, and so I'm going to create an object called mat0. And then let's see what mat0 looks like. So notice here we've got that mat0 is this matrix here. So in other words, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 all the way through. And so let's see what happens when we take the sum. So notice when we take the sum, what actually happens here is it takes the column sums instead of just summing over the entire matrix. So the sum function that takes the sum of the entire matrix has been masked by the sum function written to reproduce the sum function in MATLAB, which is the sum of the columns of the matrix. So that's just something that you want to be careful of. It doesn't happen very often, but it is just something you want to be aware of as you use different packages. And so this is going to conclude our second video. Again, these videos are just meant to give you, just enough to get started in R. There are lots and lots of tutorials online for whatever it is you're specifically trying to do in R. So usually your first step is going to be to get your data in, and then once you get your data, don't be afraid to Google what it is that you want to achieve with your data set, because more than likely somebody has already written that code and they've got it, already posted online so that you can just make some minor edits and then end up with the result that you're looking for your data set.